For section 10.3, we're going to be simplifying radicals. To do this, we need radicals to have the same roots. We've done this before. If I had the square root of 5 times the square root of 7, we could just multiply those together. It's no issue. Square root of 5 times square root of 7, square root of 5 times 7, or the square root of 7, or 35 here. Okay? The issue here is, well, what happens if I have the square root of 5 times the third root of 7? Well, those can't multiply together. They are not the same root. This has a little implied 2. This is a second root, and this is a third root, right? So at this point, we had nothing we can do with this. We kind of already learned this. So, but the homework is going to start with them being the same root. But for now, we'll go ahead and wait on this, because I'm looking at this going, okay, we cannot multiply those together the way they are. They have to be the same root. It has nothing to do with the base. It has to do with our root. So square root of 3 times the square root of 3 would be the square root of 9, which is just 3. Okay? So this is where we're going to start. If I have the square root of 10y times the square root of 3k, these can multiply together. You multiply the 10 with the 3, so we end up with the square root of 10 times 3, or 30. And then y and k don't multiply together, so we would just have k and then y. That would be it. This also works if I have a third root. So the third root of 3 times the third root of 12 would be the third root of 36. Now this time we're not, I don't want to speak too quickly, but I don't know if we're done on this one. Because if it can be simplified, we need to simplify it. So we need to check. 36 is 6 times 6. That would be 2 times 3 times 2 times 3. Well, to simplify, I need a group of 3. There are no triples of anything. There was only 2 2s and 2 3s. So this would be completely simplified. I'm looking to pull out groups of 3 on a third root. There were no groups of 3, so that is already simplified. So now let's get back to this. Well, how do I do the square root of 7 times the third root of 5? Short answer is what? We don't, right? But we've done this before, and we said, well, what if I could turn this into 7 to the what power? Well, first power, second root, so 1 half. Times, sorry about that, times, how about 5 to the 1 third? Well, now I could potentially multiply these together if they had the same denominator. So I could do that as 7 to the, let's see, 2 and 3. That would be 7 to the 3/6 times 5 to the 2/6. Now these don't multiply together and give me 35, and we can't add the exponents because they're not the same base. So we can't just add the exponents. But what I can look at and go is, now that these are the same denominator, they basically are the same root. This is the 6th root of 7 to the 3rd and the 6th root of 5 squared. So I can actually multiply those together and get the 6th root of 7 to the 3rd times 5 squared, which we can simplify. Okay, we can multiply those together, 7 to the 3rd times 5 squared. Let's see here. 7 to the 3rd times 5 squared. So 85/75. We have been able to now put those together. And that is the same thing as the square root of 7 times the third root of 5. Square root of 7. Let's see, come on now. Times the third root of 5. And we said that's the same thing as the 6th root of 85/75. How about that? So we are able to bring them together now. Once again, we do need to know how to simplify. I can sit there, and I don't recommend this, so this is another good application for the rational. If I have the 4th root of y to the 8th, I don't want to have to write out 4, and pull out groups of 4, and get y squared. Yes, I can do that. Or I can think of this as a power over a denominator. I can think of this as y to the 8 over 4 is y squared. That's easier to me if I think of it as 8 and I'm pulling out groups of 4. 8 divided by 4 comes out twice. 16 doesn't work though. I can't do 16 to the 1/4. It doesn't really help. So this one you still need to be able to do the 4th root of 16. 16 is 2 times 2 times 2 times 2. So a group of 4 comes out of that. Now you can use your calculator on that, the 4th root of 16, and simplify that. Or break it apart. So be careful because the rational exponents work really well with the variables, not so well with the numbers. So here's an example. I have the square root of 24. Let's simplify that. Well, 24 is about 6 times 4, 2 times 3 times 2 times 2. Since it's a square root, I'm looking for groups of 2. There's 2 there. So that means out comes a 2. Left inside is 2 times 3, 6. That should be old news. What do I do with the third root of a negative? It's very tempting to go no real solution, but remember, odds are okay. So I know that my result is going to have a negative, because the third root of a negative, the negative comes out. 16 is 4 times 4, 2 times 2 times 2 times 2. If I pull out my group of 3, a 2 comes out, and a 2 is going to be left on the inside. This is basically the third root of 8, which is why the 2 comes out. And this is the third root of 2, which doesn't simplify, so it's there. What do I do with the x to the 4th? Well, I could write out 4 x's and circle 1, pull an x out, leave 1 in there. I could write out 5 y's, pull out my group of 3, and that leaves us with 2 in there. I'm totally fine with that. But I want to encourage you that I can think of this as x to the 4 over 3. And what is 4 divided by 3? Right? 1 with 1 remaining. This 1 brings our 1x out. This remainder leaves that 1 in there. I can do the same thing with the y. I can think of it as y to the, I can think of it as y to the 5/3. Well, that end goes in 1 time as well, with a remainder of 2. This 1 would be the y that came out. This remainder is the 2 that are left in there. Just a different way of thinking about it, actually a little more advanced way of thinking about it. But you got a choice. You can keep writing them out, but it's going to start to become impractical. So I'm going to think about pulling out groups and seeing what's left, the remainder that's inside the root still. Third root of negative 27. I know that the third root of a negative will be negative. The third root of 27, 9 times 3, 3 times 3 times 3. So out will come a 3. Nothing left in there this time as far as the numbers goes. Y to the 7th, I'm going to think that as y to the 7/3. That goes in twice. That's the 2 y's that come out. That's 2 with what remaining? If I pull out my 2 groups of 3, I have 1 left over. That's the y left in here. If you don't like that, write out 7 y's and circle 2 groups. Leave the 1 in there. X to the 5th, I think of it as x to the 5/3. 1x comes out with 2 remaining. Z to the 6th, I think of it as z to the 6 over 3. That's just 2. That means that 2 z's come out with nothing remaining. So the z's are not left in there. They all came out. What was left in there? How about a y and 2 z's? And that would be it. Now this seems like, we're simplifying, but you're like, that doesn't seem any simpler. Well, keep in mind, radicals are complicated, and what did we do? We end up with less in the radical. That is why this is called simplifying. Okay? All right. Our last skill on this is going to be applying the Pythagorean theorem to find the distance between 2 points. See, if I can take 2, -1, and 1, 2, 3, 4, it looks like 5, 3, okay? And I would like to find the distance between them. There is two options. There is a formula for this. I'm not going to give it to you yet. Or I can say, well, I know the Pythagorean theorem on a right triangle. The legs, a squared plus b squared, are equal to the hypotenuse, c squared. You're like, well, what does that do for me? We've got 2 points. Well, if I look at it as like a rise and a run, I have now formed a right triangle with a rise from -1 to 3 of 4 and a run from 2 to 5 of 3. Now what makes me really upset is I will ask people to find the distance between these 2 points and they'll tell me the slope is 4/3. That really irritates me. This is not a distance. I literally want to know what is the distance between these 2 points. So what can we do? Well, we can take a squared plus b squared equals c squared and go, well, the a squared is going to be our 3. Change an x there. Change an x. The 4 is going to be our b, or our change in y. And the c, the hypotenuse, is going to be the distance. So 3 squared is 9, 4 squared is 16. So 25 is equal to the distance squared. When we square root, we don't get plus or minus 5 because we're dealing with distance, and distance isn't about negative, so our distance is just 5. Okay? Now, like I said, there is a formula for this. If you really like your formulas, here's what they do. I don't do, this whole formula. I do it as a squared plus b squared equals c squared. And my a is my change in the x's. The change or the distance between the x's. From 2 to 5, the x changed by 3. Change in x squared. My b, the up and down, is the change in the y values squared. And the c is the distance squared. That's the only formula I've ever needed for distance. Now I know the other formula, not because I memorized it, but because I can actually build it from this. How do you get the change in the x's? Well, this one was 5, this one was 2. It was a change of 3. You could subtract them. So they'll sit there and go, well, really, if you want the change in the x's, you would subtract them. Same thing if I wanted the change in the y's from -1 to 3. 3 minus -1, 3 plus 1 is 4. Is y2 minus y1. But I don't think that formula really looks any less intimidating. I think it's more intimidating, but there's nothing wrong with it. But then what they do is they go, well, really, I'm trying to solve for distance. So all of this needs to be under a square root. And if I square root both sides, that is just distance. This is the distance formula right here. But this makes me sad, because that looks terrifying. But all I really have to do is understand this. So you got some choices. I could sit there and take these 2 points. What were they? 2, -1. And 5, 3. And go, okay, change in the x. x2 minus x1. 3 minus a -1 squared. Now you have to be careful. You have to recognize this becomes 3 plus 1 plus y2 minus y1, 5 minus 2. But then you got to remember, I got to put a whole sucker under a square root. Start cleaning it up. This becomes 4 squared. This becomes 3 squared. This becomes the square root of 16 plus 9. This becomes the square root of 25. And the distance is 5. I'm doing basically the same thing. I just don't like that formula. I think it's more intimidating than is necessary. I'm going to go ahead and do one more quick example just to kind of illustrate this. So let's go ahead and say I'm going to take the points and what am I going to do? Now, keep in mind, when I get into trigonometry and pre-calculus, yes, I'm going to be using the distance formula, but this class, we really should be understanding where that's coming from. I'm thinking in my mind of this. -3, -5. And if you want to put all the little notches you can, but you don't have to. -1, 2. I want the distance between these points. So I'm thinking this. And to go from -3 to -1 is a distance of 2. I literally can count. From -3 to -1 is 2. From -5 to +2, be careful, it's not 3. It's 5 and 2 more. It's 7. So I now can do a squared plus b squared equals distance squared. 4 plus 49, 53, square root of 53. You don't have to do it my way, but if you do on the test, write it out this way and then make a little mistake, that to me says you understand what you're doing. If you use the formula, there are a lot of little mistakes that you can make. Let me show you. Square root of x2 minus x1 minus -5. There's the first most common mistake. Minus negative becomes plus a positive, all square. And next one, plus y2. That would be -1 minus a -3. That becomes -1 plus 3. So we have 7 squared. I'm keeping these in parentheses because sometimes these numbers end up becoming negative, which doesn't freak me out. Just basically, I'm going to square it anyway, so it's going to become positive, but that's another common mistake. Plus 2 squared. 49 plus 4. 53. Which way's right? Right? Both of these give me the same answer. In fact, this formula right here, I've not memorized. I've just built it from the Pythagorean theorem, which makes sense to me. But both ways are right. Which way's better is completely up to you. Because both ways will get you the answer. But try it. If you're trying this, drawing it out, and you're like, man, this is not working for me, then don't do it that way. If you're using the formula and you're making a bunch of mistakes, then don't do it that way. But this will be on the test, and you need to make sure that you give me the answer of distance. Do not give me 7/2. Oh my goodness, that'll make me really bad. That is not the answer. I'm not asking for the slope. I'm asking for the distance between those points.